Good morning, friends. This is my solar system with Tesla Powerwall look alike battery cabinet and the switchgear and the inverter cabinet. So these two boxes are just standard switchgear cabinets. I got them made by a switchboard builder and got a panel beater to paint them for me. So it's got a base coat and a couple of top coats and a sticker and a clay coat on it. And I also got my computer set up just down there to show you the numbers coming out from the inverter. So what I got here is I got the solar panels feeding into the 10 amp fuse there and through the DC SPD. It's going directly to the inverter down there, and I got the main incomer coming through the SPD through the incoming 2-pole breaker, and I have the battery set up on the next cabinet. So I got 7 Nissan Leaf batteries, and they are around 1.5 to 2 kilowatt hours left on them. So the batteries go through the DC circuit breaker to the inverter. So I haven't got a BMS yet, but the batteries are fully balanced and seems to be holding up pretty well because they have all come from the same car. I will have a BMS, 14S BMS, and also I would have a thermocoupler and a thermal cutoff to cut off if the batteries gets too hot. So that's still to be done, and I probably will have a second set of Nissan Leaf batteries if I have extra power generator during the day. So I got 1600 watts coming through the solar system. The maximum I've seen is about 1500 coming during the peak days, and total system cost is about $1,500, and the payback is 3 years for the whole system. So it generates around 200 kilowatt hours per month, and so that comes to be about $500 US cost saving on electricity bills. So this is my inverter, and it is rated at 5000 VA and can handle about 10,000 watts of surge power. So I have managed to run my bench saw and few big drills together, and it seems to be holding pretty well, and also a water jug which is 2000 watts, and also the oven, and they are capable of handling big currents. So right now I have the grid current or the generator current. I have a changeover outside for my generator and the grid. So you can right here I got the incoming from either the generator or the utility, and it's going to the inverter. During the day it's turned off, and the whole house is powered through the solar panels and through the batteries. Next, the output is wired through the DC breaker there, not the DC breaker, the RCD. So I got RCD protection on all my subboards as well, and they are segregated, so if one of those trips, these one won't trip. So this is the inverter. And the good part of this inverter is it can also run without the batteries. So I can turn the battery and it's purely running on solar panels. So solar panels directly to the inverter, and the system is holding on pretty well. So there are no batteries. But this one's showing the battery is connected to the battery, but it's definitely not connected, and the power is coming through the solar panels directly into my load. This is the system overview, the SCADA display, and I got the utility disconnected. The solar is generating around 300 watts. It's a really gloomy and rainy day today, and it's charging the batteries and also supplying the small load. So the total system cost for me was about $1,500, and it produces around 200 kilowatt hours a month, which equates to about $500 a year on saving. So the return on investment is 3 years. I have used good components and mostly good switchgear for safety devices, and the inverter is reasonably okay, and really good solar panels for this build. So solar panels are half cut 400 watt panels, and they're pretty efficient. They are pretty much generating about 90% of their rated wattage at this point. Thank you. Hope you enjoyed my little video.